Meron tayong bagong project. 555 oscillator. Yun, 555. Tingnan natin. Alternate flashing of the LED. Ayun, oh. Tingnan natin yung kanyang waveform. Siya ay square wave. Tingnan natin yung frequency. Siya ay 2.41 Hertz frequency. Let us examine the 555 oscillator we constructed. So this is a schematic diagram of 555 oscillator. Pin 1 grounded, 2 is connected with pin number 6 and to the capacitor, positive side, to the ground. 22 microfarad, 16 volts, electrolytic. Pin number 3 is the output. Pin number 4 reset, and pin number 8 the power of the IC. We need to connect the pin number 4 to the supply in order not to reset the circuit. Pin number 5 we don't have connection, and pin number 6 is also connected to 2 and to the 10K resistor. Pin number 6 is the threshold. Pin number 2 is the trigger pin. Pin number 7 is the discharge pin. Connected is the 680 ohms resistor and the 10K. And the R1 is connected to the 5 volt supply. We have this power indicator just to know that our circuit is on, indicating that the circuit is on. We use this LED indicator, 5.8K resistor with the LED red. We're going to construct this power LED. We need this LED. Why is it that we have an alternate flashing of the LED into the output of the 555 timer? What is the reason behind? Because here we have this R3 for 70 ohms and LED red connected to the output. Also the other LED connected to the output to the ground. We have 2 LEDs connected to the output of the 555 timer. What is the reason why is it why we have this alternate flashing of the LED? What is the reason? Why is it? In our circuit, this 555 timer serve as an oscillator. So it can produce a square wave as we have seen in the oscilloscope. Square wave. On, off, on, off. On, off, on, off. But we do not have any off. Why? Because we connected this LED. to the output. Okay, let us trace the current flow. Current flows into the capacitor, charging the capacitor by R1, R2, and then charging the capacitor. The time that capacitor is charging, it will make the output of this 555 to go high. So the current flows out, causing the LED, this LED to turn on. If this is DO, let us make this D1 and this is D2. So this D2 to turn on. Why? Because capacitor is charging, causing the current to flow into the D2. This one's a D2 LED. It will turn on the LED and the other LED will not turn on because it is reverse bias. The moment that the capacitor is discharging, after charging, it discharges through the pin number 2 and 6 and then to the 10K to the pin number 7 discharge pin. Also current flows into the R1 to the 7th discharge pin. It will now make this output to turning it into a low level. Low level. What happens if the output of the 555 timer is in a low level? It will now make the current to flow into the R3, then D1, red, and then instead of flowing the current to the another LED, it will flow inside the 555 timer and then to the ground. So during the discharging of the capacitor, current flows into the R3, D1, and then flowing inside the 555 timer to the ground. So the illusion of the two LEDs are, they are flashing alternately. If this one is on, this one is off. If this is off, this is on. Because the output of the LED is bidirectional. The current will flow inside or it will flow outward. Sometimes it is low, sometimes it is high due to the charging and discharging of capacitor. So when the capacitor is charging, current flows into the LED2, causing the LED2 to turn on, and this one is off. When this is discharging, it will the current flows into the ground, causing the current to flow from the 5 volts. The other LED will now turn on to the pin number 3 and then to the ground. So it will make this two LED, make this alternate flashing of an LED. Eto na ang ating bagong project. So dito dalawang set na ng LED, blue. Di ba? Kinonect na natin sa 5 volts. Siya ay alternate flashing of LED. Di ba? This is now the new project. Okay, still the same configuration of the 555 as the oscillator. Previously we have this design. So instead of using one LED into the 5 volts connected to the 5 volts, you're using 4 sets of LED. All LEDs are blue, 5mm in size. So from D1 to D8 we have this LED blue, and we are only using one resistor for 70 ohms. Here we are using only one resistor, but here we are using one resistor with 4 LEDs in parallel. Same here, 4 LEDs in parallel, and then to the ground with only one resistor. And we have this connection to the output. So this circuit is we're going to see the sourcing and the sinking current of the 555 oscillator. Where is the sourcing current and the sinking current of the 555? Since this 555 is capable of sourcing current, making this LED to turn on while using only one resistor. So this one, when the output of the LED is high, it will make these 4 LEDs to turn on. Okay, and with one resistor for current limiting purposes, making this LED to turn on. And when this output of the 555 is low or almost 0 volts, causing that there is a ground connection here. I forgot to include the ground connection of the LED of the 555. So during the time that the LED is the output is high, it will turn on all this LED with having with just using one resistor, and it is capable of sourcing current. Why is it that 555 is sourcing current? Because it gets its power from the 5 volts. Pin number 8 to the 555, then to the output, then to the LEDs, and then to the R resistor, and then to the ground. And then during the time that the capacitor now is discharging, before it is charging, causing the LED to turn on. This one set of LED, now it is discharging, causing now the LED is another set of LED to turn on. Using only one resistor, flowing the current flows to the output inside the LED. So the current flows from all LEDs, resistor, and then to the output, and then grounding it to the grounding by the 555. So what kind of current? This time it is now sinking current, because the 555 is sinking. It sinks current or getting its power from the ground to the ground, or from the ground. So this one is sinking current, while the other way around is sourcing current. Sourcing current because it gets getting the power from the 5 volts, and sinking current because we first the current flows into the load before the 555. So this one is a sinking current, and now the 555 is connected to the ground. If the 555 is connected to the ground, it is sinking current. If the 555 is connected to the supply, it is sourcing current. Okay? Sourcing, sinking, pushing current, pulling current. And it is capable of sinking. If each LED can consume 20 milliamps, it is the 555 that is capable of sourcing current of 80 milliamps. Since we know the current in parallel are to be divided, and the voltage is the same voltage from ground to the output. While here, since the LED is connected in parallel, the current is divided. Okay? So it is also capable of sinking current. Sinking current flows inside the 555. Sourcing current flows outside the 555. Outward sourcing.